Hey everyone, I want to welcome you guys back. I hope you had a long and restful break and are ready to get back at it. Because it's been a while since you've probably looked at some math stuff, which is totally fine, and hopefully that is the case, that you haven't looked at much. We're going to spend today and actually the course of the next couple days reviewing what we were doing before break just to kind of get settled back in. And so basically what we'll do is each day we'll be reviewing a new concept. So we're going to start with today. We can see that it is going to be a factoring review. And so what we're going to do is you'll see that there are a grand total of 16 problems here. And basically there are 4 questions within each type of factoring that we learned. So long story short, what we'll do is this. I'll do one of each example. You will be responsible for doing the remaining 3 in each type of example. And when you're all done, you will submit it and be done with Algebra 1 for the day. Okay, so that's kind of the plan. So just kind of looking again at one of each type, we could see for questions 1 through 4, factor by GCF, and GCF again was the greatest common factor. So what we wanted to do in this case was look at each term and see what do all of them have in common. What's the biggest thing that we can take out of each? So when we look at this first example, 4x to the 9th plus 12 times x to the 4th. Remember, we first look at the numbers. So when I look at 4 and I look at 12, I ask, what's the biggest thing I could take out of each? Well, the factors of 4 are 1 and 4, 2 and 2. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Now, some of us may not need to write those factors out, and you're good right away. Others may need it, and that's totally fine. It's whatever you need. As we look at each of these, we can see that the greatest factor, or the largest number they both have in common, is this 4 right here. So what we're going to do is we're going to take that 4 and we're going to factor it out. I'm going to write it out front. Eventually there'll be a set of parentheses as well. But that 4 comes out. The next thing I look at then is I look at the x's. So I can see that I have x to the 9th and x to the 4th. So I've got 9 x's in the first term. I've got 4 x's in the second. So when I ask what's the most number of x's that I could take out of each, that is going to be 4. I could take 4 x's out of the first, and I could take 4 x's out of the second. So x to the 4th is going to come out to the outside of the parentheses. So the GCF in this case, the thing that both the first and second term have in common, they both have a 4 and an x to the 4th. So we're going to factor that out, and then inside the parentheses, we're going to write what would be left over. Okay, so going one piece at a time, this 4 divided by 4 is 1. We really don't have to write that 1 in there, so we can just remove that for right now. And then x to the 9th divided by x to the 4th, I've got 9 x's. We've taken 4 out, so we're left with 1 times x to the 5th, which is just x to the 5th. Then we carry down our plus sign, and now it'll be 12 divided by the 4 is 3. X to the 4th divided by x to the 4th is just 1. If I take 4 x's out of 4 x's, there's nothing left over in terms of x's, so that is the end. So a lot of different colors here, so I'll just kind of finalize it. Our final answer is 4x to the 4th times x to the 5th plus 3. Okay, that is factoring by GCF, taking out whatever the highest value is between numbers and variables out of each term that we can. Okay, so you'll have to do examples 2, 3, and 4 on your own. Okay, now going down to this next one, we can see factor each quadratic of the form x squared plus bx plus c. Okay, this is when we did that diamond type problem where, let me make this a little bigger. It kind of helped maybe to think about, okay, if we multiply the two numbers, that goes on top, add the numbers that goes on bottom, and we asked ourselves, what two numbers are going to multiply to the top and add to the bottom? That's the same case here. We want to know what two numbers are going to multiply to C and are going to add to B. Okay, that's our goal for these types of problems. So when I look at number 5, x squared plus 4x minus 12, I ask myself, what two numbers are going to multiply to negative 12 and are going to add to positive 4? We've talked about this several times. If we're going to multiply to a negative number, that means one of the two values or factors have to be negative. So for example, if I did negative 1 and 12, negative 1 times 12 is negative 12. When I add those, I get positive 11, so that's no good. If I did positive 1 and negative 12, that's still going to multiply to negative 12, but 1 and negative 12 is negative 11. So we see that these two are really just opposites. So rather than checking every single combination, I'll just check one pair of positive and negative. And if I end up getting a negative 4 when I want positive 4, I know I just need to flip whichever one has the negative. Okay, so my next option would be negative 2 times 6. Negative 2 times 6 is negative 12. Negative 2 plus 6 is positive 4. Perfect, there's my answer. So the two factors are negative 2 and 6. So in our first set of parentheses, that's going to be x minus 2. We're just taking this minus 2 and putting it in right there. And then x plus 6, taking the positive 6, dropping it in there. This right here is our final answer. X minus 2 times x plus 6. Okay, so that's factoring x squared plus bx plus c. You've got 3 more examples you'll need to practice on your own. All right, now slight difference here. If we're factoring, in this case, ax squared plus bx plus c, we see that there's this a in front of the x squared. Okay, and it might just seem like a little difference, but it changes really the whole way we go about solving. And what we're going to do is we're going to take a first step that we didn't have to in this case because there was no number in front of the x squared. So in this case, if we have something in front of the x squared, we're going to do something that we call the AC method, which is we're going to take this first number and we are going to multiply it to this last number. 3 times negative 5 to get negative 15. Okay. Now, what we're going to do is we are going to take that negative 15 and put it back into our answer. We're going to temporarily remove the 3 and have x squared minus 2x, and then instead of the minus 5, we're going to replace that with the minus 15 that we just found. Okay. Reason we do this is so that way we now have a problem that's just a regular x squared plus bx plus c, something that we're more confident and comfortable with. So now what we want to do is ask ourselves what two numbers are going to multiply to negative 15 and add to negative 2. So again, since we're multiplying to a negative, one of the factors has to be negative. Negative 1 and 15 comes out to be positive 14. If we flipped those to be positive 1 and negative 15, we would get negative 14. So that's not going to be the case. 2 is not a factor of 15, so let's try negative 3 and positive 5. Negative 3 and positive 5 adds to positive 2. We want negative 2, so that means I just need to flip these. Positive 3, negative 5, that comes out to be negative 2. Okay, so those are the two factors we wanted. So if you recall, what we do next is we take the original equation and we rewrite it. 3x squared, but now instead of writing it as minus 2x, I'm going to split it into these two factors, plus 3x minus 5x. Okay, so we took this minus 2x and we split it into the two factors, plus 3x and minus 5x. And then I go back to my original ending, minus 5. Once we get to this point, the next thing we did was we grouped the first two terms and the second two terms. Group the first two and the second two. Now it becomes a GCF problem, just like we had at the very beginning of our review. I look at the first set, 3x squared plus 3x. What can I take out of each of those? Well, numerically, I could take this 3 out of each, and variable-wise, don't know how this happened here. There we go. Variable-wise, I have an x squared, and I have an x. Well, I could take 1x out of each. So if we do that, 3 divided by 3 is 1. I don't need to write that. X squared divided by x is just x. Plus sign comes down. 3 divided by 3 is 1. X divided by x is still 1. Okay, it's just itself. So 3x plus 1. Now we go over here to this side. One thing that stands out to me right away is this negative. Okay, we don't want that negative out in front, so I have to factor out a negative. Then, when I look at the numbers, 5 and 5, I can obviously take a 5 out of each. This first term has an x, the second one does not, so I can't take an x out of anything. So now, if I do negative 5 divided by negative 5, that's just 1. X divided by, there isn't an x to take away, so it's just x. And again, we don't need that 1 there. Negative 5 divided by negative 5 is positive 1. And then our last step, okay, hopefully we recall seeing this. Whatever's inside our parentheses should be the same. I've got an x plus 1 in each set. So my first factor is x plus 1. My second factor is whatever was on the outside of the parentheses, 3x minus 5. Okay, so one more time to quickly review this. If we have a number out in front of the x squared, we take that number and we multiply it with our ending constant. 3 times negative 5 was negative 15. We then take that negative 15 and we place it at the end of the problem. We do not write the 3 in front of the x squared because we borrowed it to the back with the negative 15. We then take that quadratic and we treat it just like our regular x squared plus bx plus c. We find our factors. In this case, it was 3 and negative 5. From there, we rewrite the original, but we split that middle, that minus 2x, we split it into our two factors, a positive 3x and a minus 5x. Then we chunk the first two terms together and the second two terms together, factor out the GCF from each, okay? These are far and away the most challenging. So if you struggle with these ones, do not worry, okay? You are not alone, okay? These are tough problems to do. Excuse me. Okay, and then lastly, we have difference of squares. So remember, this word difference means to subtract, and squares meant numbers that when you take the square root of them, you get a whole number, no decimals, anything like that. Okay, and this was a special shortcut that we ended up learning, so we'll just kind of jump to that. When I look at this first example here, I see 16x squared minus 9. Here's my subtraction, or my difference. 16 is a perfect square. X squared is a perfect square. 9 is a perfect square, which means when I take the square root of 16, I get 4. When I take the square root of x squared, I get x. And when I take the square root of 9, I get 3. Therefore, when I set up my sets of parentheses, I take this first set of answers, 4x and 4x, to start in each set of parentheses. And then I take this last answer, 3, and I put it at the end of each set of parentheses. And if you remember, there's no middle term. There's no term with just an x. We have an x squared, we have a constant, but there's nothing in the middle. So in order to cancel out that middle term, if you remember our shortcut, one was a plus, one was a minus. What this ends up doing is it ends up canceling out our middle term. So our final answer, 4x plus 3, 4x minus 3. And where'd that come from? Difference of squares, we take the square root of each part and plug in. Okay. If you have any questions, I know it's been a while, you could watch the previous video lessons that were made. You can rewatch this one as many times as you need. You can email me, and I strongly encourage you to do so. Email me, send me a message through Schoology. We can start some sort of dialogue between the two of us. Anything I can do to support you during this time, I really want to make sure that I'm doing. So with that being said, thank you for watching, and I look to hear from you soon. Take care.